Hello and welcome to week 11 for junior cycle ordinary level. So today we're going to split the lesson into two parts. The first part will be dealing with introduction to functions and linear functions, and the second part will be quadratic functions. So we've introduction to functions and linear functions. And then the second part, as I said, is going to be quadratic functions. Now at the very end as well, we'll be doing some exam questions just to tie everything up. Okay, so a couple of things about functions first of all. So a function is a map, and a map that takes one number and maps it onto another. Okay, so that's what we're going to write down as our definition for a function. So a function is a map. And it maps one number onto another. Now, this will be explained a little bit better when we do examples, but we usually use the letter f to denote a function, and it's given by a number x. The mapping of x under f is written as the f of x. So we usually write the rule as the f of x, and that is the function. So we could have something like the f of x is equal to 3x. Now what that means is the rule that you need to apply is 3 multiplied by x. Now x could be a range of different values. So if I wanted to get, we'll say, the f of 1. So instead of x, I'd put in 1. So here's the rule. So we put 1 into the place of x. So that's going to be 3 by 1, and that will give you 3. So your result there would be 3. Now there are 3 ways of writing functions, and I'm going to write the 3 ways up here in the corner just so you remember them. So the first way is the f of x equals, which is the one we've just met. Second way is f colon x goes to. That's another way of writing it. And then the third way, which is really important as well, is that y is equal to. And they all mean the exact same thing, and they're all functions. So you might see it written any of the 3 ways, and you should be able to recognise all 3. So we're going to look at a mapping diagram now. And a mapping diagram shows how a function can be applied to create a range of outputs. So usually what we have for a mapping diagram is we have 2 ovals, and we have our x values. So I'm going to put in the values 1, 2 and 3. Now, what we call this is the domain, and this is our input values. Okay, so the domain are the x values that you're going to plug into the rule. Now we're going to say the rule here is 3x. So what we're going to do is plug 1 into the rule, which we actually did there. So the f of x, so the f of 1 is 3x. That's going to be 3 by 1. So 3 by 1 gives us 3, and that's our output. Then we're going to plug the number 2 into the function, so 2 in the place of x, so 3 by 2. So 3 by 2, and that gives us 6. And then finally we're going to plug 3 into the function, so 3 by 3, and that gives us 9. Now these are the set of y values, and they're also known as the codomain or range. And they're output values as well. So the range is the set of all of the actual outputs, and the range will always be contained in the codomain, okay? So I'll just show you here. 1 maps onto 3, 2 maps onto 6, and 3 maps onto 9. So we say there that the range is 3, 6 and 9 because they are all numbers that have been mapped on from 1, 2 and 3. So I'm going to show you another example where we have a codomain and a range. So if we had something like this, so we've 2 of our ovals, sorry they're not very good shapes, but you get the idea. So we have the domain, and if I put the values 1, 2 and 3 in, so this is the domain, so these are my x values, and I put in the numbers 3, 4, 5, 6 and 7, and I'm going to join 1 to 3, 2 to 5 and 3 to 6. Now you can see there that 3, 5 and 6, they're all mapped from numbers that are in the domain. So we call 3, 5 and 6, we call that the range. So the range is a set of actual outputs, okay? Just going to write up here, so the range is the set of actual outputs. And the codomain is all of the possible outputs. So you'll see in the diagram there that not all of the outputs, they're not all mapped. So 4, nothing is actually mapped onto 4 and nothing is mapped onto 6. So the codomain is all of the possible outputs. So it's everything there. So 3, 4, 5, 6 and 7. So it's very important that you recognize that the range are the numbers that are actually mapped on from something else. So 3, 5 and 6. And the codomain are all of the possible outputs there. So that's really, really important as well. So we're going to go on to plotting linear functions now. So with linear functions, they generally take the form y is equal to ax plus b, whereby you have a number attached to an x, so coefficient attached to an x, and you just have a constant on its own. Now, examples of linear functions would be y is equal to 2x plus 1, y is equal to, or the f of x, we'll do it a different way this time, the f of x is equal to 2x plus 5, or the f going to x is 3x plus 1. So they're all examples of linear functions. Now, it's called linear because when we plot the function, it's going to be in a straight line. So if you got a question, so we'll say you were asked to plot the function, the f of x is equal to 2x plus 5. And it told you in the domain minus 3 is less than or equal to x is less than or equal to 2. What that means is your x values should range from minus 3 all the way up to 2. So let's create a table here which will help us to plot. So I'm going to put my x values here. My rule, so the f of x is equal to 2x plus 5, and then my y values. And we're going to get some corresponding points then, or couples or ordered pairs. So our x values are minus 3, minus 2, minus 1, 0, 1 and 2. So we're putting that into the function. So the f of minus 3, so you're plugging minus 3 anywhere you see x. So 2 by minus 3 plus 5. That gives us minus 6 plus 5, which brings us to minus 1. The next one is the f of minus 2. So that's going to be 2 by minus 2 plus 5. So that's minus 4 plus 5, which will bring us to 1. The next one, the f of minus 1, is going to be 2 by minus 1 plus 5. So that's minus 2 plus 5, which will bring us to 3. The f of 0 is 2 by 0 plus 5. That's going to give us 5. The f of 1 is going to be 2 by 1 plus 5, and that will bring us to 7. And finally, the f of 2 is 2 by 2 plus 5, and that will give us 9. Now, if we were to put them into pairs, or x and y values, the first pair will be minus 3, minus 1. The next one is minus 2, 1. The next one is minus 1, 3. The next one is 0, 5. The next one is 1, 7. And the final one then is 2, 9. So the idea is to plot these on a coordinate diagram, and I'm going to paste in now what it should look like. So I've pasted it in there now. You see the first point there, minus 3, minus 1. So minus 3 on the x-axis, minus 1 on the y-axis. That's your first point. The next point is minus 2, minus 1. So minus 2 on the x-axis and up to minus 1 should I say, on the y-axis. That's the next point. The next point after that is minus 1, 3. So minus 1 is there and up to 3, that point. The next point is 0, 5. So 0 on the x-axis and 5 on the y-axis. Second last point is 1 and 7, so 1 on the x-axis all the way up to 7. That's that point. And then finally the point 2, 9, so 2 on the x-axis and all the way up to 9 on the y-axis. So as you can see, that forms a straight line. But you should know that that forms a straight line by looking at the function. The function is a coefficient in front of x plus a constant, so that would indicate to you that it's going to give you a straight line. So we're going to move on to quadratic functions now, and then we'll do some questions that come up on linear functions and quadratic functions. So we're now moving on to quadratic functions. Now, if we're dealing with quadratic functions, it takes the general formula. I'll just write it out here. So the f of x is equal to ax squared plus bx plus c. So you have this x squared term, and there might be a number in front of it, so a coefficient in front of it, or there might not be, it might just be x squared. You have a number attached to an x, so a coefficient of x, and you have a constant as well. Now, examples of this would be the f of x is equal to x squared plus 2x plus 1. Another example would be y is equal to x squared minus 5x plus 4. And another example, the f of x is 2x squared plus 3x plus 1. So they're all examples of quadratic functions because you can see the x squared term is present in all of them. Now, we should know what a quadratic function will look like. And there's a way of telling, there's two options really. So the first option, option A, is where you have a function that looks like a U. And the second option for a quadratic is where you have a curve in the shape of an N. Now, the way you tell the difference as to which one it's going to be is you look at the x squared term. So if we look at this function here, you look at the x squared term. Now that's positive because we don't see any sign in front of it. So if the x squared term is positive, it's a u. Okay, so I'm just going to write that in. So x squared term is positive. So that means that you're going to get a shape of a u. Now, if you got an x squared term that was negative, so I'm just going to make one of these negative just to show you. So I'll turn that into a negative. So the x squared term is negative there. It would take this shape, and think n for negative. So if the x squared term is negative, it's in the shape of an n. So you can tell kind of straight away what shape your graph should be. So the x squared term is negative, it's going to be in the shape of an n. So we're going to look at a particular function now. We're going to plot the table, and then I'll show you what it should look like. So if you were asked to plot the function, the f of x is equal to x squared minus 5x plus 4. And it's in the domain. So the domain are your x values. So if you're asked for in the domain of -1, less than or equal to x is less than or equal to 5. So you're going from -1 to 5. So we'll create our table then again. So you're starting at -1, 0, 1, 2, 3, 4, and 5. Now your rule is the f of x is equal to x squared minus 5x plus 4. So you're plugging that rule in, and you're going to get your y values. So this here is going to be -1 squared minus 5 by 1 plus 4. So what I've done there is I put -1 in anywhere I see x. So instead of x squared, it's -1 squared. Instead of 5x, it's 5 by 1. So when you put that into the calculator, you get a result of 10. So the next one is 0 squared minus 5 by 0 plus 4 will give you a result of 4. Now I'm just going to write out the couples or the pairs as I go. So -1 and 10 is the first point. 0 and 4 is the next point. Next one is going to be 1 squared minus 5 by 1 plus 4. And again, when you put that into the calculator, you'll get 0. So this point here is going to be 1, 0. Next point then is 2 squared minus 5 by 2 plus 4. And that will give us -2 when you put it into the calculator. So the point is 2 minus 2. Then we go on to 3. So 3 squared minus 5 by 3 plus 4. And that will give us a result of -2 as well. So you have the point 3 minus 2. Then we have 4 squared minus 5 by 4 plus 4. So again, I'm just plugging 4 into where x should be. That'll give us the result of 0. So the point is 4, 0. And then 5 squared minus 5 by 5 plus 4. And that result will give us 4. So the final point then is going to be 5, 4. So the idea is to plot these points. Now, if we look at the function, look at the x squared term. So it's positive because we don't see any other sign in front of it, which means it's positive. So we would think then that our function is going to be in a U shape. So I'm just going to paste up what it should look like now. So you can see there, it is in fact in the shape of a U. We'll just go through the points. Minus 1, 10. So that's 0, that's minus 2. So minus 1 will be somewhere here. And minus 1, 10 will be that point there. Next point is 0, 4. So 0 on the x-axis and up to 4 on the y-axis. That's that point. 1, 0. So 1 on the x-axis will be here and 0. It doesn't move. Next point is 2. Minus 2. So drop. That's that point. Next point is 3 minus 2. So in between 2 and 4 is 3. And drop to minus 2. Next point is 4, 0. And the last point then is 5, 4. So 5 would be roughly here. In between 4 and 6, up we go, up to 5, 4. And as you can see, this is in the shape of an U, which would indicate that the quadratic function, the x squared term, is positive. So that's kind of the theory on quadratic functions and linear functions. So we're going to do some questions now to push this theory into practice. So I've taken this from paper 1, 2018, and it's question 8. So Emma is going to some exercise classes in a gym. The graphs below show the cost per month of 2 different gyms, Gym A and Gym B, for up to 10 classes. Based on the graphs, complete the following sentences correctly. So if Emma goes to 6 classes per month in Gym B, it will cost how much euro? So we can see that the number of classes are on the x-axis. So we go to where 6 classes is, so it's going to be here. And what we need to do is go up and see where it hits Gym B. So remember, Gym B is this line here. So we need to go to 6 and go up until it hits Gym B. And we come across then, and it's 50 euro. So that's the answer there. So it's 50. Gym A and Gym B cost the same for how many classes per month? Now, if they cost the same, that's where they intersect. That's where they cross each other. And they only cross at one point, which is here. Now it's asking you how many classes does it cost the same for. If we come down here, it gives us 4, and that's 4 is the number of classes per month. So the answer there to that question is 4. If Emma goes to 10 classes per month, then Gym what will be cheaper. So we go to where 10 classes a month is. So 10 classes a month is here. So we'll see how much it costs for Gym B. So we'll go across. So it's 70 euro for Gym B. Then if we go back to 10 and go up to Gym A, it costs 100 euro for Gym A. So if Emma goes to 10 classes per month, then Gym B will be cheaper because it costs 70 euro. So fill in the 2 missing values to complete the following statement correctly. Gym B costs how much per month plus how much for each class. So the cost per month is what you start at. So if we look at B, which is Gym B here, it doesn't start at 0, it actually starts at 20. So that means that it's starting at 20 euro per month. So it's 20 euro per month. That's what we start with. And then it asks plus how much euro for each class. So how much euro for each class. So if we look here, for one class, the difference between one class and 2 classes is a jump of 5 because that's 25 and that's 30. The difference between 2 classes and 3 classes again is 5 because it jumps between 30 and 35. So that means that it must cost 5 euro for each class. So that's the answer to that one. So I'm going to put up another question now on the next slide. So this is also paper 1 2018. Now, this question is part B as well, but I'm just going to do part A on this slide and I'll do part B on the next slide. So you were asked to draw a graph of the following function in the domain -2 is less than or equal to x is less than or equal to 2. And the function is y is equal to 2x plus 3. So we need to create our function table. So our x values are going to go from -2 up to 2. So -2, -1, 0, 1 and 2. And then our rule is the f of x equal 2x plus 3, or y, either of them is fine. Now, I'm going to plug these into the rules. So 2 by minus 2 plus 3, so your y values. That's minus 4 plus 3, which brings you to minus 1. So our couple or a pair will be minus 2, minus 1. Next one is 2 by minus 1 plus 3. So that's minus 2 plus 3, which will bring us to 1. So the point there is minus 1, 1. And the next point then is 2 by 0 plus 3, which is 3. So the point is 0, 3. The next point is 2 by 1 plus 3, and that's 2 plus 3, which is 5. So that's 1, 5. And finally, 2 by 2 plus 3. So that's 4 plus 3, which is 7. And the couple there will be 2 and 7. So we're going to plot these points. The first point, minus 2, minus 1. So minus 2 on the x-axis is here and minus 1 on the y-axis down here. So that first point is going to go there. Now if we look at the formula, it's y is equal to 2x plus 3. So we know it's going to be linear because it's in the form ax plus b. Next point there is minus 1, 1. So minus 1 on the x-axis is here and 1 on the y-axis is up to here. So there's our point. So that's going to go there. The next one is 0, 3. The point 0, 3 is there. 1, 5, which is going to go here. And then finally the point 2, 7, which will go here. So what I suggest you do with this is you definitely need to get a ruler and you draw the best fit line that you can. And just draw like so. So that's the linear function complete. So I'll do the quadratic function now on the next slide. So this is part B of the same question. It's still paper 1, 2018. So this time you can see that the function has an x squared term, which means it's going to be a quadratic function. Now, the x squared term is positive, so we know it's going to be in a U shape. So it's saying the domain minus 2 is less than or equal to x is less than or equal to 2. So we'll create our table. So our x values go from minus 2, minus 1, 0, 1, 2. Our rule is y is equal to x squared minus 1. So that's the rule we're going to be using. And our y value. So x squared minus 1, so it's minus 2 squared minus 1. Now be careful here, when you square a negative number it becomes positive. So minus 2 squared is 4, 4 minus 1 is 3. So your first point there is minus 2, 3. The next point then is going to be minus 1 squared minus 1. So minus 1 squared is 1, 1 minus 1 is 0. So the next point is minus 1, 0. Next point is 0 squared minus 1. So that's going to give us minus 1. So 0 minus 1. Next point is 1 squared. So 1 squared minus 1. That's 1 minus 1, which is 0. Next point is 1, 0. And the last point then, 2. So we put in 2 squared minus 1, which is 4 minus 1, which is 3. And that's going to be the point 2 and 3. So we're going to plot these points now. So the first point there is minus 2, 3. So minus 2 on the x-axis here and 3 is there. So that's where the first point goes. Next point is minus 1, 0. So go to minus 1 on the x-axis and 0 on the y-axis. It doesn't move. So that's the point. Next point then is 0 minus 1. So 0 on the x-axis here is dropped to minus 1 is going to go here. Next point is 1, 0. So 1 on the x-axis and 0 on the y-axis is there. So that's the next point. And then finally the point 2, 3. So the point 2 on the x-axis is there and 3 on the y-axis is up here. So 2, 3, and that's it. Now what you draw here is the best curve that you can. So you just usually use a pencil with this and you just join up all of the points like so. And that's your quadratic function done. Now yours will look a lot better than mine because I'm drawing on a tablet here, but yeah, try and join up the points as best you can with that, and definitely be able to recognize that that is a quadratic by looking at the x squared term. So we predicted that it was going to be a U shape, and it is in fact a U shape. So we have time for another question. So this is to do with plotting points as well, and then we have to answer 2 questions at the end. So this is from paper 1, 2013. So The points 2, 4, 3, 6, 4, 8 and 5, 10 are four couples of a function. Plot the four couples. So the point 2, 4. So 2 on the x-axis and 4 on the y-axis. So 2 on the x-axis go up to 4 on the y-axis is going to be there. So we draw in our first point. Our next point is 3, 6. So we go to where 3 is on the x-axis and all the way up to 6 on the y-axis, which is going to be there. Next point is 4, 8. So 4 on the x-axis and up to 8 on the y-axis, which is going to be here. And the last point then is the point 5, 10. So 5 on the x-axis and all the way up to 10 on the y-axis, which is there. So then what you do is you get your ruler and you're going to join all of the points up. And again, you just draw the best fit line you can. So that's the first part done. Now, part B. The function f is derived from a rule. Suggest a rule for f. Now, the way we do this is let's look at the couples that we have. So there are x values and our y values. So the first couple there we have is the points 2 and 4. So x is 2 and y is 4. So delete that. X is 2 and y is 4. So how did you get from 2 to 4? There was a rule there that mapped x onto y. So it looks like you're adding 2, but let's just double check with the rest of them. The next point we have is 3 and 6. How did you get from 3 to 6? So it's not adding 2. So how did you get from 3 to 6? So it's not adding 2, it's actually adding 3. So what about if we suggested that you multiply the x value by 2? 2 by 2 brings you to 4. 3 by 2 brings you to 6. Let's check the others. 4 and 8. That works as well because 2 by 4 brings you to 8. And finally 5 and 10. And again, 5 by 2 gives you 10. So the rule there is 2x. And I'll just show you. So 2 by 2 gives you 4. 3 by 2 gives you 6. 4 by 2 gives you 8. And 5 by 2 gives you 10. So the rule there is the f of x is equal to 2x. And then on your diagram, plot and label two other couples which could be got from the same rule. So the same rule, if I decided to keep going, so what the x values we have are 2, 3, 4, 5. If I went for 6 and 7. So 6 and 7. So 6 by 2 is 12 and 7 by 2 is 14. So that would be the point 6, 12 and 7, 14. And you're asked to plot them. So the point 6, 12, so 6 is here. And all the way up to 12, I actually kind of have it marked in already. So the point 6, 12 would be there. And the point 7, 14. So the point 7, 14, so 7 on the x-axis and all the way up to 14 would be up here. What you could do then is get your ruler and just join the last point up so that everything is nice and even. So I'd suggest going back over that and making sure that you're able to plot points. And remember that x always maps onto y using our rule. So in this case, it's 2x. So I'm going to attach some extra links and video tutorials in the chat. And I'd suggest that you follow them and go back over what we've covered this week. And I will speak to you next week.